is we'll make that token. And I feel like we just need to review this so much because a lot of you are still having trouble making these collectible token things, right? So I still see that when I'm walking around that a lot of you are struggling with this. So if I want to make a collectible token, which one of these is that? Actor. And guys, please, everyone pay attention. I know you want to work on your finals, but this above everything, like you have to have something collectible in your final. Yes. I use pawns. You'd use a pawn if you have like a ship or something that flies around that doesn't need all that character stuff, like the collision. Actually, like I think even Christina could be a pawn. Did I spell this wrong? Did I spell collectible? I can't see. Anyway, okay. So I'll add the token. Let's see. I'll make it maybe. No, I'll just make a sphere. All right. So is this enough for my token? No. What else do I need? Right. Okay. I need the collision. Okay. There. Perfect. So I'll name it. So I have everything referenced. So how do I create some programming from this token? How do I create some event that when Christina collects this token, something's going to happen? Begin overlap. Okay, so I go right here to do that. What? Here, is this going to work? No, it's not going to work. This is what I see. I see this mistake a lot. Why won't this work? I'm not programming the collision. What am I programming? The sphere, which doesn't have that overlap event. I have to select the collision. Do you see that difference? Do you guys see what I have selected there? Now I have the collision selected right here, and now I can do begin overlap. And I'll see right here it says collision, right? If I select this one and do that, it's going to say token. But I can't program a collision event from that token because that's just not what it's made to do. It's just made to be geometry. That's it. It's made to be a little sphere. You can do whatever you want. You can make an ice cream cone out of it. But in this case, we want it to create an event, a collision event. Right? So that's why I add the collision to it, and I program off of that. Does everyone understand that? I hope so. This is like the #1 mistake I see when I'm walking around, that people aren't programming the collision event properly. Okay. So we only want Christina to overlap with this, so what do? What's that? Cast it, right? Yep, cast. Cast to Christina. Okay. And then I want to make it go away, but before it goes away, I want like some particles to pop up. So what would I do for that? Yep. Perfect. Spawn emitter at location. And then to get the location is very easy. I'm just going to say get actor location. And the reference is the self because we're in the token blueprint. So we're just getting like where is this token at, right? Okay. So I made an emitter called got token. One important thing to review about emitters. What's an important thing about emitters? Because I don't want it to go forever. Give it a lifespan, right? So under required, if I just type in loop up here, we see emitter loops, and I set that to 1 from 0. If it's at 0, what would that do? It would continuously loop, right? And then it would never end. Yeah. Yeah, you should definitely have this somewhere. I also did a few things under initial velocity. Wait, what is it? Yeah, under initial velocity, under distribution, I just set this to an even number, so I have like this even explosion, right? So it's not just going up, like on default. So do you guys see that? Okay. If you wanted, that would be really cool. I would say go in Photoshop and just make a circle that's a PNG, right? And then, so these aren't just little squares. Do you know what I mean? Like you can do a lot of really, really cool stuff with particles. We could do a whole class on it, but that's as far as we'll take it so far. Okay, so we spawn the emitter, and then what? We want to make it go away.
Remove? No.
Nope, that's for widgets. Destroy, yep. So we destroy it, and then it goes away. Voila. So now we can test. Let's just test one of these. So there it is. You can see it. Boom. Right? Okay, so that's working. But are we counting how many of these there are or anything? No. So we need to like program this a little bit. Right now, all it's doing is it's just this thing. When you bump into it, it goes. But before we do that, let's set a few of these in the level. So I'm setting the collectible token class in my level. When I set it in the level, what does it become? Do you guys remember that programming terminology? A what?
Vector?
Not a vector. It has a vector, right, under details. The location vector, 70, 170, negative 120, that's the vector. What is it? When a class has some customization to it, because this class, right, now has a certain vector. Each class has a different vector. So when a class has these kind of custom variables, what is it called? Do you remember? That was something we learned like the first day. An object, exactly. So that's called object-oriented programming, right? So anytime you guys learn programming, every single programming language is that nowadays that you would learn, like JavaScript, C++, C#, it's object-oriented, like this, okay? So hopefully maybe you would be able to understand that a little quicker because you've used Unreal. I don't know. That's my hope. Ali, what are you doing on your phone, man?
Nothing.
Okay. So now next, let's give these, before we start to program them as collectible things, let's give them some color. Because right now they're all black. You can barely see them. You can't even see that one at all. Let's give them some color. So I'm going to do that. You could do it anywhere, really, but I'm going to do it in Christina's blueprint just because I'm going to do it at the same time as I get the variable to count them, right? So I don't need to physically go in here and count them, right? Like you could go here and go like 1, 2, 3, 4, 5, 6, and then you're like, okay, I know I have 6. But then if you add a couple later or something, you'd have to change all your code. So it's better to code in a way where you have the computer count them. Because that's what computers are way better at than us, is counting. All right? So we're going to count them with this really, really important node called get all actors of class. Okay. So a class in Unreal is this dark purple, and actors are the same thing as objects. Objects are blue. Okay. So the class we're going to get is the collectible token. And now because we learned on Tuesday what this little square thing is, what is that? What? An array. So why would that be an array? Yeah, because you're getting a bunch of them. There's multiple actors. Okay, so now this all actors of class becomes an array. Okay, and I can pull that out and just type in length to get the length of that array. And what would the length tell me? How many actors are in the level? How many objects of that class we put down, right? What's that? Exist. Yep. Is this making sense? Right. So then I can make a variable in Christina called all the tokens or whatever. I called it something else on the screenshot. That's an integer. And I can set that to the length. Okay, so now we know all the tokens, that's going to tell us, right? So I could say print and now when it starts, it'll count them for us. So I hit play, and we see there's 6 of them. I don't know what that 3 is from. Something else. Okay. So we can delete that. Now, while we're getting them all, we might as well assign some material to them. Right? So I'm doing this on the event begin play, right? But of course, there's like a million different cool ways you could do this, right? Like maybe when Christina gets some key, then all of the tokens suddenly appear because they have a color, right? And so that key would be like an actor blueprint with a collision. When she collides with it, then there's an event there, right? And then you would get all these actors of the class and assign a material to them so they appear or something, right? Okay, so we can take that out of these out actors, and now we're going to run a for loop for each loop. Let's see, I'll try to keep this pretty. Now, this is a for loop we're doing with an array. You don't have to do it like that. You could just do a regular for loop where you tell it how long you want it to go for. So if I say 0 to 5, that's doing the same thing, right? The advantage of this for each loop when we're using the array is each array element, it'll spit it out on this end so I can do something with it. So as it's going 0, 1, 2, 3, 4, 5, each time it pulls out a unique token. Do you guys get that? Let's maybe, let me do something first before we even, so every time I hit F, we'll go here, and I'll say print, and we'll print this out, loop body here, and we'll say complete print for loop done. So it's going to cycle through this loop. Every time I hit F, it's going to cycle through how many times? 6. Good job. I tried to trick you guys. I didn't do it. So it's going to cycle through 6 times. So what's it going to print out? What are we going to see in the print string? What? What's that? One of them? But it's a loop, right? And it's looping 6 times. Yeah, so we'll see 0, 1, 2, 3, 4, 5. Pretty much at the same time. Ready? Let's see, I'll let this finish. Okay, so here's Christina. So as soon as I hit F, they all show up at the same time, and then it says loop done. Why do you think they all show up at the same time? What's that? Yeah, it's all one array, and also they all show up at the same time because computers are really, really fast, right? That's as fast as the processor ticks, these things show up, right? It seems like at the same time, it's like they all show up within like a microsecond increment, right? Do you guys get that? Okay. Does that help you visually see how a loop works? Kinda. For loop done, right? Any questions about that? What's that? Yeah. It's looping 6 times. Each time, it's printing the index of a loop. Let me see how else I could explain it.
I think it would be a little better if you actually did it like in the game.
Yeah, that's what I'm about to do here. Okay, so let's do it in the game. Okay, so here's a for loop. We're taking, instead of first index, last index, we're just taking all the tokens, and we're going to run it however many times, however many tokens there are. Do you understand that? So how many tokens are there? 6. So how many times will this for loop run? 6 times. Okay. Each time it runs, it's going to pull out. This is also exactly the same as get. Right? So each time it runs, it's going to get that index of the array. So the first time it's going to run, it's going to get the first token. The second time it runs, it's going to get the second token. Third time it runs, it'll get the third token. Right? And that's coming out of here. So we have a reference to that token out of here. So I can pull this out and say get token. There it is. And from this token, I can say set material. All right, what do you think? Do you kind of get it? All right, I'll just do it. Let me finish it, and then we can talk about it more. So I'm going to set the material. Okay, before we set it randomly, let's just set all the tokens to be green. So I'm going to say save. Now we hit play, and look at that. All the tokens are green. Okay. I can go in here. I can set the tokens to be purple. Hit play. Now all my tokens are purple. Right? Because it's going through each one. Right? Notice this is an array here. And is it an array here when it comes out? Is this an array here? No. This is pulling out of an array. Right? It's pulling. So in the same way that we have this material array, right? It's pulling 0, 1, and then 2. But in this case, it's an array of these tokens. Do you guys understand that kind of? A little bit? Yep.
I can't get the token thing.
Yep.
I'm doing it for the enemy, I can't get it.
Which blueprint are you doing? Do it in like your in the Javier blueprint.
Yeah.
That's where you are? Okay. Instead of the enemy, you have to pull out the shape that the enemy is. So say get Jeremy or whatever you called it. Right? So I'm pulling out, when I say token right here, it's this. So if I rename this to, I don't know, coin, and hit compile, notice it changed right here. Do you guys see that? Right? So if I rename this to, what else? Treasure. Hit compile. What's it going to say in Christina? Treasure. I'm pulling out, it's just this circle. It's not the whole thing. It's just this circle because this sphere circle is where we have the material. The collision doesn't have material. The default scene root doesn't have material. The self reference doesn't have material. It's just this treasure. Okay? So that's what I'm pulling out and setting the material on. Yep.
You had more than one geometry and you wanted to get all of them?
So good question. So say we had 2 treasures. So say I had like a cube on there. Something like some weird shape like this, right? Whoa, where'd I go? Right, so say I had this, okay? And if I wanted to set that, I would pull this out, and I would have to say get cube. And then I would set it like that, right? So now we can hit play, and they're all going to be brown, right? And it's assigning it to both. Now, if I wanted this cube to be something different, I could say set material. And I could set that to blue. Right? Okay. So that's a little boring. Let's assign each one to be random, which would be more interesting, right? All right, so I can pull out my material array that we made on Tuesday. So we made these 3 materials. And I'm just going to do get to get a random part of the array. So how do I get a random number? get random, or sorry, it's just random int in range. And let's see, I'm just going to take a shortcut. I know there's 3, so I'm just going to say 0 to 3. We could, of course, pull out the length and do all that stuff, but I'm just going quick. Yes. How many do we have? Yes, there would be. Thank you very much, Trevor. So 0 to 2, because we have 0, 1, 2. Okay. And then same thing we'll do right here. So I just copy pasted. So now when I hit play, we have all these random colors. And each time I hit play, it's going to be different. Let's see. I could also add some interesting things like a rotator. I think we talked about this. Rotating movement.
Yeah, we did.
Yep. So now when I hit play, we have all different colors, and they're moving around. Right? Which you can't really see because they're moving around on the z-axis. We could take this and like play around with it a little bit. I don't know. What's it going to do now? No, not that interesting. But whatever. You can also do a random rotator, but we're not going to let's not get too into it. Okay. Any questions up to this point? Let's see. I'll make this code a little neater. Oh, it's hard to keep this organized. Okay. All right. So we're counting the tokens, making a variable telling us how many. Then we're going to run a for loop that runs through each token and assigns the treasure geometry a random material, and it assigns the cube geometry a random material. All right? Do you all understand that? Yeah? Okay, we need to go back in our collectible token now because we're not counting it at all, right? All that's happening is Christina goes into it, it collects it, it goes away, and she bumps into it and it goes away. We need to give her a variable called how many tokens collected, right? Okay, and it's an integer, starts at 0, so we don't need to put anything in there. Okay, so each time she collects a token, this is super important because you all have to do this. You all have to collect or subtract something. So I'm going to move this a bit over here. We're going to connect that later. Let's maybe put this up here. So each time she collects a token, we're going to go into Christina because we're in the token blueprint now. We're going to get how many tokens collected. We're also going to get all the tokens, so we know how many there are, right? We'll need that. We need that for later. And we're also going to set how many tokens collected. What are we going to set how many tokens collected as? What's that? No, because we just want to add to her score. So how do we add to her score? We've done this now like 3 or 4 times.
That plus thingy.
A plus thingy, yeah. We take how many tokens collected, and what do? Add one to it, yeah. We just say plus. Integer plus integer, exactly. And then I connect that to that. Okay, so now her score just went up by 1. Okay, cool. So now if we wanted, we could say print, because we're just going along testing everything, and destroy it. So now we have a counter, right? Now every time she bumps into one, there we go, 1, 2, I'm gonna die. Okay, right? Okay, but we need more, right? What else? What is the one other step we need? Because we want to open the portal only when she collects them all. So what do we need to check for every time she collides with one?
How many coins collected?
Yeah, not necessarily how many, because we don't, I mean, we just added that up. But what are we checking more precisely? If she has a certain number, what is that number? What's the number we're checking for? All the tokens. This variable, whatever it is. So that way, if I add one more token, nothing in my code needs to change. Right? There's another one. Who cares, right? Because now that's just going to change to 7. Right? So this variable just changed to 7, but we don't even need to bother with it. The computer bothers with that. So we're checking if how many tokens collected equals all the tokens. So we can pull this out and say equals and connect that to all the tokens. Are you guys with me? Most of this stuff is not new, right? Most of this is not new. And in fact, really, at this point, nothing is new. Okay, so we're checking do how many tokens collected equal all the tokens. If that's true, okay, if that's true, we're going to grab another variable from Christina, and we'll make this a Boolean, all tokens collected. That's a Boolean. What's a Boolean again? True or false, right? So if that's true, set all tokens collected to what? To true. Yep. And then we destroy the actor. And if it's false, we just destroy the actor. So if how many tokens collected does not equal all the tokens, we destroy the actor. If how many tokens collected does equal all the tokens, we set all tokens collected to true. So that way, we can go back to our teleporting actor, get all tokens collected, and we can set a branch up. So only run all this code. We're only going to run this teleporter if this is true, right? So we just kind of set up a switch, which is really all computers do at the core. They're just a bunch of little electronic switches. Do you all understand that? So the only way we're going to run this blueprint, essentially, is if she has all the tokens. And so now I think we're all done. So there's our random thing. They're rotating. We don't see a visual count, but they are being counted, right? Oh. So that one didn't get destroyed. Oops. All right, let's restart. That was cool though, right?
Yeah.
You
made it. Yay.
Okay. Boom. Sometimes when you jump up stuff from the top. So look, now this doesn't work, right? This doesn't work. Now I get, oops, oh no. What did I do? It's too far over, right? Oh boy, let's try again. So you can see a few things that I need to tweak, right? Okay, it's not working. And now it works, right? What would I do too programmatically? Like, would I always keep this yellow? When would this turn yellow? When you get all the stuff, right? That's when it should turn yellow. So you could do something also in the collectible token. You know, here's something a little more advanced. You don't have to do this, but we could say get all actors of class. We're gonna get the teleporting actor because the only event we have is when she overlaps, right? So we're going to get all, and then we can say get 0 because there's only one teleporting actor, right? So we know it's going to be 0. And so what I'm going to do is take out this material, and let's just make it white. And then that is called cylinder. So I'll say get cylinder, set material, and now we'll make it that yellow. And then we'll destroy. Do you guys kind of understand what I just did? This is a little more advanced, but not really, right? It's just we're just using that get all actors of class again. But in this case, it does say it's an array, but in fact, it's just an array of one thing. It's just got one thing in it. All right, now I have to not mess up. But see, it's white. Boom, now it's yellow. And now we know we can interact with it, right? If it's always yellow, that's a little weird because it always feels like you can interact with it. Yay, I won. Okay, that's the lesson. Any questions?